Welcome to qnawire.
For this problem on the topic of light waves, we have a thin piece of paper with thickness 0.02 millimeters and refractive index 1.45 pasted across one of these slits in a Young's double slit experiment. 4/9 of the light energy is transmitted when passing through the paper, and we want to find the ratio of the maximum intensity to the minimum intensity in the fringe pattern. We want to know how many fringes will cross through the center if an identical piece of paper is pasted on the other slit as well, if the wavelength of light is 600 nanometers. Now, we'll let I1 be the intensity of the source without paper. So we'll simply let I1 be I, and I2 the intensity of the source with the paper. And so I2 is 4/9 times I. And so we have a ratio of I1 to I2 to be 9/4, which means that the ratio of amplitudes R1 over R2 is equal to 3/2. And this is since the intensities I are proportional to the square of the amplitudes. Now, we therefore have the maximum intensity to the minimum intensity to be R1 plus R2 all squared divided by R1 minus R2 all squared. And using the above, we get this ratio to be 25:1. Now for part B, the number of fringes that will cross the origin is given by n, and n is equal to the refractive index mu minus 1 times the thickness t divided by the wavelength lambda. And so this is equal to 1.45 minus 1 times the thickness, which is 0.02 times 10 to the minus 3, all divided by the wavelength of light, which is 600 nanometers, or 600 times 10 to the minus 9 meters. This gives the number of fringes crossing the origin to be 15.